Hello everyone, I am here to present a project named Used Car Price Prediction using Machine Learning. Myself Rahul Ojha from ISMT College. This is the project I have worked on. The dataset I have used is provided by Car website, which is basically an automotive e-commerce company where they sell used as well as new cars. So let me run the code. So at first I have imported the libraries needed to run the project. I have imported NumPy to do some mathematical as well as numerical analysis, pandas for importing and loading the dataset, Seaborn and matplotlib for data visualization technique. So after importing data, let's do some data exploration techniques. So the dataset consists of 8128 rows and 13 columns. This gives the information about the dataset. To make sure whether the dataset consists of null values or not, we use pandas is null method. As we can see, there are various missing values. So to address this missing value, we do some data pre-processing and cleaning techniques in the next section. So this gives the description of the dataset. So yeah, as you can see, there is no null, no missing values, as I have dropped all the entities, duplicated entities. Now after pre-processing the dataset, this dataset consists of 6712 rows and 13 columns. The information about the dataset is shown like so. Again, using value count methods, which is provided by pandas, we are able to know the value count of fuel, seller type, transmission and owner respectively. So let's move to data visualization technique. So at first we are interested to know the numeric part of the dataset. So I listed down all the numeric part of the dataset. So I have used pair plot to understand the best set of feature and to know the relation between two variable. So the below plot tells that automatic car sells at higher prices. This plot explains the price sold by first owner is significantly more compared to second, third and fourth owner. This plot gives an idea that the cars sold by an dealer is higher compared to individual and trust mark dealer. So now this plot gives an idea that the number of year as the number of year increases, the selling price of car also increases. To know the relationship between different brands and selling price, we found that Maruti has higher selling price compared to any other brand. Top 10 expensive vehicle is provided by this plot. As we can see, Volvo XC19 T8 Excellence BSIV IB has largest sold at very large price. Now, similarly, top mileage car is provided by this plot. Now let's move to feature engineering. So earlier we were interested about the numerical part of the dataset. Now let's explore some categorical features. So as we can see, we have the columns of the dataset consist of categorical features are the name of the car, fuel, seller type, transmission and owner. So we are converting every data type to float data type. So as we can see, all the columns of the dataset is now float 64. Similarly, to keep only numerical feature, uh, I have removed the string features. As we know, scaling is very important in machine learning. We use min max scalar, which subtracts the minimum value in the features and then divide by the range, and the range is the difference between the original maximum and original minimum. Also, the best part about min-max feature is that it preserves the shape of the original distribution. Now again, we have used heat maps to better visualize the events within dataset. They are nothing but the graphical representation of the data where they utilize color coded system. So now let's move to model fitting and evaluation, where we do basically training and evaluation part of the machine learning. So now in model fitting and evaluation, we are importing all the libraries which are needed to train the machine learning models. So I have used trend test split, decision tree regressor, random forest regressor, matrix, which is used to monitor the performance of model during training and testing. Different machine learning algorithm techniques and evaluation metrics are imported. So we are dropping the selling price. It is a Y level, and we put in Y column. I have used trend test split method to split the data into train and test dataset. As we can see, 80% of our data is used for training, while only 20% of the data is used for testing. And the shape of X train is consists of 5,369 rows and 42 columns. So now the model building and evaluation part. At first we have used linear regression model, and it gives the accuracy of about 73%. The mean absolute error, mean squared error, and root mean squared error is given, as we can see. These are the evaluation metrics used in especially regression techniques. Now I have also used scatter plot to look how the model outperforms. I have also used distribution plot to know about the density of selling prices. So next algorithm I have used is KNN. So the KNN is actually used for both classification as well as regression method. So the KNN algorithm gives the accuracy of 86%. The different MAE, MSE and RMSE value is 0.009, 0.0031 and 0.001765 respectively. And the next algorithm is random forest regressor, which is actually ensemble learning method for both classification and regression. The accuracy of the model is 91%. The decision tree regressor is actually used for classification as well as regression also, and it breaks down a dataset into smaller dataset. The decision tree regressor gives an accuracy of 83%. Similarly, I have also used XGBoost regression, especially to avoid overfitting, as it is a highly scalable training method. So it gives an accuracy of 92%, and the MAE, MSE and RMSE are 0.0074. MSE is 0.000165 and RMSE is 0.012. So yeah, the evaluation parameter, the XGBoost regression outperformed, uh, as it has highest accuracy out of three different algorithm, as well as lower error in all three evaluation. Second, we have random forest regressor with accuracy of 91%, and least accurate method is linear regression, only 73%. So this brings us to the end of the project. Thank you.